Welcome, folks, to another Midweek with Max. This is Rick, joined by Joshua, John Greenwood, Antonio, JCV, and of course our co-founder Max Sanchez. So, without further ado, let's kick it off with Max.
All right, sounds good. So quick update on the engineering side. We've been doing a lot of work with ZK provability, so making a lot of good progress there. We had kind of a 0 to 1 moment late last week or this week with getting HVM, the new ZK Merkleized data format for all of the Bitcoin indexing needed for HVM precompile calls and HVM state transitions, working and running on the RISC-0 ZK VM end-to-end. And also basically feature parity in Rust with the new ZK indexer that we're adding, or that we've added to the Go version of TBC. So still working on doing a review and verification of all the constraints we're applying in the ZK state transition function and all the witness validation pieces, and looking at some performance optimizations, and obviously running it through a battery of tests with mainnet data, testnet data, and some synthetic tests to look at edge cases. But we should be hopefully open sourcing that relatively soon if people want to take a look, or if you're interested and eligible on the ZK side, if you want to contribute. That's a great area of new, interesting development to contribute to. So hopefully sooner rather than later, we'll be open sourcing components of that maybe in the next few weeks here. Beyond that, been making a lot of progress on what we've been kind of codenaming MinerFi. And just as a reminder, it's bigger than MinerFi. That was sort of the original impetus for creating the system, but it's really a Bitcoin fast bridge system that wraps around the Bitcoin tunnel using liquidity providers, and then also a DeFi router for automatically composing Hemi BTC deposited on chain and routing that into different DeFi protocols or different strategies. So being able to have a dedicated Bitcoin deposit address and being able to send Bitcoin to that and have it automatically do things in the Hemi DeFi ecosystem on your behalf. So, for example, being able to say you mine Bitcoin, register an address and put it in the mining pool, and then every day your mining profits that are distributed by the pool automatically get converted into Hemi BTC behind the scenes for you and put into our upcoming staked Hemi BTC product, which is part of this bigger Hemi Earn initiative that we'll talk about probably a bit more in the coming weeks, or auto converted into other assets if you're need to pay capex expenditures for your mining or whatever. But more broadly, it could also be integrated into other sort of non off-chain crypto solutions and providers. So, for example, exchanges could integrate the DeFi router system with a fast bridge to automatically deposit BTC that you withdraw from the exchange directly into Hemi DeFi and be able to manage your portfolio right from the exchange interface. So a lot of cool integrations that we can do with that, just making Bitcoin, DeFi, and Hemi easier to access, easier to use, and being able to have configurable control over your portfolio management to be able to delegate parts of it out to a third party who's providing some convenience for you without giving them actual control over the assets, but just the ability to change portfolio allocations of that incoming stream of Bitcoin to your dedicated deposit address. So that's moving along. We've also started working on these smart contracts for the MinerFi side. So the backend daemon's progressing, working through some edge cases and optimizations around the threshold signature key generation, key resharing system. And then hopefully by the end of this week, we'll have an MVP of the MinerFi contracts that we'll be using internally to hook everything up to. And then maybe sometime mid to late February, actually doing a testnet deployment to start playing around with the actual system end to end and doing some public testing of that. Let's see, beyond that, a lot of other miscellaneous cleanup things. We are getting ready to activate the Jovian hard fork. So there's a couple items on the Hemi specific side that we're getting into that release. So there's just one upgrade. There's going to be some small tweaks to some items in HVM. And then there's also some minor changes to gas pricing of some precompiles and things of that nature. So we'll be putting up a hippo that covers those comprehensively, and then getting that activation scheduled once we're done with testing. Also, we've on the pop payouts V2 side, we got that deployed to testnet, and it activates today at, I believe, 2 p.m. Eastern. So in about 3 hours from now, that'll activate on testnet. And so anyone who wants to play around with the new V2 payouts algorithm, if you play around with it and do pop mining on testnet this afternoon, you will be part of the new pop payouts V2 testing system on testnet. It's not incentivized, so it's just purely if you want to play around with it, look at the mechanics. Also, if you want to read through the source code, let me link to that. So if you want to understand the actual payout algorithm and how it works, you can check out, it's been open source for a few weeks. I believe I may have shared it last week as well. But you can go there and look at the smart contract code for that. And there's also a lot of tests. If you want to run some economic simulations, you can look at those, the testing framework, and see how we do testing for various scenarios of publications at different heights in the system. And you can use that to write your own tests that simulate different economic conditions and look at how the payouts adjust to that dynamically. The token on testnet that's paid out is just a dummy ERC20 token for testing everything end to end. Obviously, on mainnet, it would be the actual Hemi token, but on testnet, we don't really have that. We have the original like T Hemi token from the old pop mining days, but that's part of the old governance token. That's protocol minted, so we just did a dummy ERC20 to test the parts we actually care about there. So let's see, we have that. We're also we should be doing the next VE Hemi rewards distribution by the end of this week. So we did all the internal accounting of protocol revenue since the last distribution at the end of October. And so we have final numbers for that. And so we should be getting that out end of this week, assuming everyone on the team signs off on the final split for the new distribution. And I think that's pretty much everything on the engineering side since last week. I don't know, JCV, if you had any other items that I may have missed.
No, I think you hit not only all of it, but a couple things I forgot about. So,
All right, awesome. And one other minor thing, we are doing some changes to the database handling in TBC. So it's not going to be if you're already running a V2 node, either for testnet or mainnet, a V2 as in the upgrade to TBC database V4, which we call Hemi Network V2. It's a little confusing because there are different versions of all the subcomponents, but we are doing an update to make the database behind TBC a little more abstracted, so we can swap it out with different underlying implementations. And so, not sure whether that's going to make it in for the Jovian hard fork or not, because it is more of a backend, code cleanup, reducing technical debt, making things easier to do in the future on the database side. But there's also some work there that you may see if you're tracking the Hemi network repo. And again, as we get the Jovian hard fork scheduled, we will announce details of whether that update's included or not. Either way, if you're running one of the old V1 nodes that still uses the old V1 version of the Hemi network repo internally, regardless of whether we include that database update with the abstraction layer, there will be a database upgrade that you need to wait to have performed for you. In a mainnet, it takes, depending on the server you're running it on, roughly 18 to 48 hours, depending on disk performance, CPU, and everything. And so we'll be providing instructions for that. And if you're running a mission critical node that you can't have go down, we'd recommend you clone the node, run the old version while you have one doing the upgrade, and then switch over to the new version. But again, when the actual Jovian hard forks you will have to do that update. We will no longer be supporting the old V1 nodes, and so you will have to take that database migration into account. All right, cool. I think with that, that's actually all of the engineering updates, and I will throw it back to Rick, and we can start going through questions.
All right, sir. Starting off with some roadmap questions. What are Hemi's biggest priorities for Q1?
Definitely the two biggest on the engineering side are MinerFi and ZK provability. So on the ZK/HBitVM roadmap, and I know probably some people are tired of hearing sort of the breakdown here, but for anyone who's interested, there's sort of two stages to ZK provability. And the first one is sort of a subset of the second one. So the first version of ZK provability is ZK proving HVM state transitions and ZK proving HVM precompiles and ZK proving EVM, Hemi EVM or HVM state transitions for executing transactions. And that will allow us to do ZK settlement to Ethereum. So we'll be upgrading the Ethereum tunnel with full ZK provability. we may, and we have to wait for all the ZK stuff to land, so this is not a critical priority to sort out, but we're either going to go with initially a optimistic ZK system where everything's ZK provable, but it only gets ZK proven if there's a permissionless challenge to a posted ZK root, or we'll go the full everything ZK by default route, which is more expensive for the protocol, but also lets you do faster withdrawals and settlement to the Ethereum side because you don't need to provide that waiting period for somebody to detect an invalid ZK or an invalid state root proof, challenge it, and then force somebody else to do the actual ZK calculation. So eventually it'll be fully ZK because once we have HBit VM, we're going to need everything to be fully ZK proven anyway. But HBit VM is based on the sort of phase 2 of ZK provability, which is all of the previous stuff. And I forgot to mention DA verification of underlying DA publications of Hemi blocks that actually constitute the EVM state transitions. So all that's phase 1. Phase 2 is what we need for HBit VM. So it's all of that plus the additional proofs of Bitcoin and Ethereum state being tracked together. And that also requires the introduction of the new type of pop publications that are going to take Ethereum attestation data and publish that to Bitcoin. And so once we get phase 1 complete, we can do ZK settlement for the Ethereum side of the tunnel. And then once we get phase 2 complete of the ZK provability, plus the introduction of the new pop publication mechanism and ZK proving of those proofs and viewing Bitcoin and Ethereum state together and making sure that they're both consistent based on publications between the chains and HVM knowledge of Bitcoin and Ethereum state through HVM precompiles, then that's what we need for HBit VM. And so that's probably Q2 for HBit VM, late Q1 or early Q2 for the lighter phase 1 ZK provability that gets us ZK settlement to the Ethereum base layer for the Ethereum tunnel. And then what was the question? So it was priorities. So biggest priority is that phase 1 ZK verification, making progress on that, and then launching the MinerFi, quote unquote MinerFi. It's really the fast bridge and the Hemi BTC DeFi routing system, which should be done by the end of Q1 as well.
Right. Sticking with roadmap questions. Here is a popular one. Is there a new NFT marketplace in the pipeline?
I will throw that question over to John Greenwood.
Working with Randau right now. They're looking to do some RNG related stuff. And then on top of that, they have some partners that they're looking to onboard, one of them being an NFT marketplace. So definitely still poking around with this. There's some orders of operations, though, as previously mentioned, due to like the randomness functionality and some other things that are kind of prerequisites for those guys to come on board. So we're talking to the right people and working with the right people on that. So hopefully very soon we'll get that taken care of on the RNG side. And then from there, it opens the door for kind of the larger NFT players to come. That was one of their requirements. So following that order of operations to get a little bit of a bigger fish in play, hopefully. And as soon as I know more, I'll let you know.
Awesome. That will make Miracle very happy, even though Miracle shockingly did not ask that question. All right. With Ethereum regularly upgrading and getting faster and cheaper, potentially reducing the need for L2s, what makes Hemi different from other L2s?
Good question. I'll take this in two parts. So first, Ethereum updating or upgrading, getting faster and cheaper. A lot of that is a function of L2s in the first place. So the actual on-chain gas budget of Ethereum has not increased that dramatically since, 2-3 years ago when we saw crazy surges and people were paying, hundreds of dollars to do a swap transaction at some points. So most of the reason Ethereum is cheap today is because of L2s. So if L2s were to magically disappear, all that congestion would go back to the Ethereum base layer. 95% plus of it would not be executed because it wouldn't be economically viable to do so. And we'd be back to square one with Ethereum not scaling. So I wouldn't say it's the Ethereum upgrades that are making Ethereum faster and cheaper. It is L2s themselves that have caused that. And then Ethereum upgrades have made it so that L2s can scale even more by increasing the First, by switching from needing to use call data to this special system for DA using Ethereum blobs and KZG proofs, but then expanding that footprint with sort of the roadmap towards true full dank sharding, and with the latest Fusaka upgrade, adding in the distributed DA storage and retrieval system with PureDAS, which makes it, we didn't really need that to scale Ethereum to 12 or 15 block targets for Ethereum, but it sets the stage for future increases to amounts that would become unsustainable for Ethereum full nodes, even with the 18-ish day blob pruning cycle that we currently have. So I'd flip it around and say L2s are the reason Ethereum's faster and cheaper today, because most of the traffic has been moved to the L2s. And Ethereum's upgrades haven't really made Ethereum that much more scalable natively as just on the L1 base layer. They've made L2s more capable and cheaper to scale Ethereum even more. And so L2s are still a critical part of Ethereum's scaling roadmap. It's pretty much the entirety of Ethereum's scaling roadmap is this L2 centricity. So I think L2s are as relevant as ever. The second part of the question, what makes Hemi different from other L2s? So say, for example, Ethereum switched to, back to the original roadmap for sharding and having a ton of different protocol native L1 shards that people can move different state to and do different things on, and then eventually settle back to this smaller integrated kind of base chain, if you will, under all of it. A, that's not going to happen, but B, even if that did, L2s are still a great way to introduce additional features and things that you can't do on Ethereum natively. And so in the case of Hemi, it's a perfect example of that. We're doing tons of Bitcoin related stuff with HVM and HBK that you could not implement natively on Ethereum, no matter what the gas limit was. I mean, theoretically, if you had trillions of gas per block, you could actually run a Bitcoin full node in the EVM, but that's never going to happen. And so L2s aren't just a means of scaling transaction throughput and the total gas that the Ethereum ecosystem can consume per second or whatever unit of time you want to look at, but it's also a way to scale features, try new experiments, and be able to, in Hemi's case, do all these Bitcoin-specific things that you could not build a smart contract on Ethereum to do, regardless of whatever the gas budget was. And also for, other L2s have been experimenting with EVM changes that improve ZK provability performance, or changes to the overall architecture that provide more privacy. And so those are things that need protocol level modifications. And you can do those, quote unquote, easily on an L2 because you control the entire protocol end to end. All you need to do is make sure you write the correct connective tissue to settle back to Ethereum, or, in Hemi's case, Ethereum and Bitcoin, in order to do whatever you want to do and support those new features you're building. Whereas if you were stuck with just the Ethereum base layer, you're limited to just what the current EVM implementation in Ethereum is capable of doing. And if you want to add a feature that needs a protocol level thing, if you couldn't build L2s, you'd have to go build a competing L1, which is not going to be nearly as interoperable with the Ethereum ecosystem. It's going to have more trust assumptions around cross-chain data routing than an L2 has. And it's just overall going to be a worse experience for people wanting to move assets from Ethereum to another chain to take advantage of those features, or people who want to do something on the remote chain using its features, but also be able to benefit from sort of mutual intelligibility of what's actually happening on Ethereum, or in Hemi's case, Ethereum and Bitcoin, and be able to actually use that in the contracts that also take advantage of the new features on that now no longer L2, but other, competing L1 chain. So L2s are, I'd say, as important to Ethereum scaling as ever. They're the reason Ethereum's cheap and fast. And beyond just scalability, they're, I'd say, even maybe a more exciting use case, certainly from a what you can do technically perspective, is the ability to rapidly add new features without needing the entire Ethereum ecosystem to agree to do a hard fork to the network to change the protocol. So for example, if we were going to build Hemi with the HVM and HBK feature sets from the beginning, and we were to do it all on the Ethereum base layer, so it wouldn't be, Hemi as a chain, but it'd be Hemi as like an in-EVM protocol. It would basically be impossible without getting the Ethereum ecosystem to adopt an update to embed a Bitcoin node in the EVM, which, as many people can probably guess, would never happen. So important from scalability still, and that's going to continue to become increasingly important, but also from the feature diversity side and being able to experiment with new things, get them to market. And, for some things, L2s will adopt them first. People will see the utility of it and then try to get them adopted into the Ethereum base layer as well. But a lot of things just aren't things that make sense for every Ethereum user to need or don't justify the technical complexity of adding in like a Bitcoin full node embedded in the EVM. And the only way to realistically do those with access and interoperability with Ethereum is through an L2 or L2 tree of chains, L3, etc. architecture.
And one bit I'd want to add is, so on the sort of space, cost, and all of that front, if so Ethereum gets cheaper and can fit more stuff in it, that's great. And that leads the L2s to have more ability to, fit transactions, fit data, do their thing. And so if there was a fixed amount of need, there was just X amount of data, X amount of transactions that we need, then yes, Ethereum could eventually get to a point where, hell with it, we don't need L2s anymore. But that's not the way things work. As people come up with new use cases, as people build new things, the demand for space grows also. But sometimes as the supply for space grows, that opens up the opportunity for people to do new things with that space. So, what the L2s are doing, Ethereum, as it keeps up, it leaves the L2s to provide for, more supply for more demand and lets people try new things. And maybe those are things that, maybe you have some crazy new protocol, lending protocol that you want to try that does something absolutely batshit crazy. Do it on a cheap L2. And, maybe you'll find some way to use up that data. But the point is, it's kind of like disk space. It's not like, well, hard disk got to be a certain size and then, everyone's good. As disk got bigger, we found new and sometimes useful, sometimes not ways to use up that space. And that's kind of the way I think blockchain space and gas is. As the things get bigger, people will be creative and find new ways to use it, and the two sides push back and forth against each other, just as long as things stay healthy and we still have people in crypto and people building new things, there's going to be back and forth and both sides are going to push on it. And that's great. That's what we want.
Yeah, that's a great point to kind of extend the hard drive analogy. Technology in general, the speed of CPUs, multi-core hard drives, moving from spinning disks to SSDs to NVMEs. The ideal case is that the performance of the underlying technology outstrips demand, because then that lets it makes everything cheaper for everyone, and then B, encourages that innovation. People say, wow, I've got a bunch of really cheap gas. What new things can I do with that I couldn't do a year ago, 6 months ago, whatever? And the cool thing is, for the most part, we're in that space now with the Ethereum ecosystem. So, roll back to pre L2s or the early days where they were using call data. When Optimism and Arbitrum basically first came out, there was, even with the call data, DA, they scaled Ethereum because they were able to at least offload the compute, but not the data storage. And, Ethereum, they were basically overpaying for data because it was being stored in a much more permanent and on-chain and accessible way on the Ethereum side that was actually needed. But at that point, we really didn't have, at that point, demand was outstripping supply. And so Ethereum fees were extremely high. And if you wanted to do something new, instead of your main priority being the business logic of it, how do I build this new protocol that does these cool new things with lending and it needs all this extra compute to do all these extra checks? It was instead about how can I build the most efficient bare bones version of this thing that I want to build that people will actually be able to run without it costing more to do a transaction than interacting with the protocol is even worth. And now, with DA being out to do Ethereum, that being scaled out, seeing a bunch of new L2 architectures launch, leverage that new DA system. Some L2s move on to non-Ethereum DA systems for very cheap stuff, like if you're going to build a gaming-centric chain where every action in a game creates an on-chain transaction. Right, Ethereum DA is not even cheap enough for you, and you need to go with a EigenDA or Celestia or Espresso or something like that. And so the we're now in a place where there is ample compute, and if you have an idea for a DeFi protocol, your concern is no longer creating the most efficient version of it, which may be feature limited, it may not be as secure. Now you can worry about the actual use case of the DeFi protocol, what should it actually do, and gas is no longer as much of a concern. Obviously, you still want to optimize your contracts, make things as cheap as possible. We've seen congestion on L2s, bases consistently, last time I checked, very, very full with transactions, even with an extremely high gas limit. So, there are exceptions to that in certain areas of the L2 space, but if you're building some new protocol, you have plenty of other L2s you could launch it on and do things much more cheaply. And if, some of those chains fill up, there's a lot of robust cross-chain functionality now, and even more coming with sort of the second wave of ZK cross-chain interoperability that you can leverage to now scale across to multiple L2s and take advantage of where gas is potentially the cheapest. In certain cases for, certain smart contract architectures. And so a couple of years ago, we were at the point where supply was extremely constrained and demand had to fit into it. And 90% of the demand there was for doing DeFi in the Ethereum ecosystem was not actually being able to be fulfilled, which limited the utility of the Ethereum ecosystem and all the assets on it in general. Now we flipped it around, and compute's relatively cheap, data is relatively cheap, and it's more about building brand new DeFi innovations and without the constraints of, or at least significant of constraints on gas limits for execution. And so we're now in the stage where we're promoting a lot more DeFi innovation because we've now got to a point where the performance of the ecosystem as a whole has dramatically outstripped supply. And so back to JCV's thing, if everyone waited for demand to be at a breaking point where people couldn't do most of the things they wanted to do before we made bigger hard drives or faster SSDs or faster CPUs, and the innovation cycle would be a lot longer versus, with most people probably have a very powerful processor in their computer that does more than they actually needed to do most times that they're using it. And yeah, sometimes you fully load it for something and, you wish it was a little faster, but the majority of the time, your CPU is not being used to its full potential. That's the ideal case because now you can think of new things that you want to do that make your life easier, other people's lives easier, better, add value, and you have the spare resources to do that without having to wait for some other big tech revolution. And so I think the scalability dramatically increases that innovation rate. And so it's better to have supply ahead of demand than the other way around. And obviously there's some actors who love demand outstripping supply, a lot of the miners collecting the fees. But for everyone else in the ecosystem and the utility of it in general, it's way better for supply to run ahead of demand and basically pull people in to create new innovations because they have that extra cash budget to work with. A longer answer than needed for that, but it's a great question.
No, it was a great answer also and very appreciated. Speaking of new innovations, I believe JCV is going to have very strong opinions about this question. Discord user Tapati Tapati. This is the new segment called Rick Butcher's Discord names. But anyway, the question is: in the future, can we see a new project on Hemi created by the Hemi team itself?
Definitely. So obviously we're more focused on like protocol level stuff, and some of those are quote unquote projects where they are on-chain smart contracts that do stuff, but they're sort of in service of the overall Hemi protocol. So things like MinerFi, anyone could go build the MinerFi system we're building, and it could be a separate product with its own brand and its own potentially token that might be a little hard to justify, but like those are effectively on Hemi projects built by the team, but they're just under sort of the Hemi protocol umbrella because we're building them and we're integrating them into other parts of the Hemi ecosystem. As far as things that sort of stand on their own, yes and no. I mean, in the short term, we're probably not going to build an NFT market or anything like that. There's teams dedicated to that who that's their world. They're better at that. They have the time and resources to do that. We're better off spending our resources, hardening the base protocol layer and making it more feature rich and faster and more secure for all of those people to then use and build their stuff on top of. So there's a bit of a specialization piece to this. There are some things that you could kind of consider projects on Hemi that we're creating, but again, they're mostly in service of the overall protocol utility even if they do operate as sort of an independent application on Hemi, if you will. So one of those is a Bitcoin MEV marketplace. There's also some other stuff we've been talking about. This is a little more future thinking, but it's an interesting sort of Bitcoin infrastructure piece of doing a private Bitcoin mempool with fully homomorphic encryption to be, or possibly a simpler version with some MPC type decryption scheme. But basically being able to, one of the things you'll see being talked about in the Ethereum ecosystem is MEV protection. Obviously, that's been a thing for years. But one of the newer solutions to that has been a encrypted mempool. And there's a couple different challenges to building an encrypted mempool. So the first is obviously the people building the blocks. They can't just include encrypted transactions if they don't know what they do. So on the Ethereum side, for example, you don't know how much gas those transactions consume. And so you don't know how many of them do you put into a block and make sure that your block's still legitimate. Now, there's ways around that. Everyone could do a ZK proof of their transactions, execution, and you could use that when assembling the block, but then you also have ordering issues. And that's sort of the goal with MEV is a miner doesn't know how to order transactions to benefit them, or block builder with, proposer builder separation. But also it means a lot of the conveniences we get with things like MEV Boost and other, MEV marketplaces, they also can't do as well because they don't actually know what your transaction's doing. So if they're trying to, do even things that benefit the user in some cases, there's mutual MEV extraction that can be done. You lose out on that with encrypted mempools. The other thing is how we actually get the decrypted data, because you have a miner who builds a block that contains encrypted transactions, but they can't actually seal the block if they can't run execution on that and compute the final state root. In order for that, they'd need the transactions in the clear, which would defeat the purpose because now they've decrypted them. And so we're not solving ZK mempools or encrypted mempools on the Ethereum side, at least not yet, although that could be an interesting future item. But on Bitcoin, it's actually a lot easier because Bitcoin's UTXO model, Bitcoin's simpler, so you don't have this arbitrary compute logic of one Bitcoin transaction that affects another. But also with the UTXO model, the execution environment it's running in is a lot simpler, and you can actually prove things in ZK about the validity of a transaction in the context of other transactions. Or you can use other techniques to give sort of a false positive list using more traditional things like Bloom filters, and you can demonstrate that a transaction is valid in a block as long as it doesn't conflict with any other transactions that have a overlapping Bloom filter for a set of potential probabilistic, set of UTXOs that it spends. And so you can use that to build basically this private Bitcoin mempool that Bitcoin miners can construct blocks containing all the transactions, but they don't actually see those until they actually perform the proof of work to mine a block. And so it does require there be a group either running the MPC system or the FHE system, but then eventually collaboratively decrypt the transactions to give to the miner to construct the final block. And so there's some, latency concerns, but on Bitcoin, that's a lot less important than Ethereum. And it'd be a way to basically be able to have a completely private Bitcoin mempool powered by Hemi, it could hook into the MEV marketplace, and it'd be totally permissionless. So instead of, right now, there's some infrastructure on the Bitcoin side. Say you're a whale and you're moving Bitcoin around and you don't want people to see your transaction in the mempool until it's actually executed and say deposit on an exchange or whatever, then you can submit your Bitcoin transaction to a specific pool, and they may promise to keep that transaction secret and not propagate it to the rest of the peer-to-peer network, or reveal it to the people mining on the pool or whatever. And that sort of works, but it's a worse experience for the user because your transaction can only get mined by a subset of the Bitcoin mining power. Basically, the mining power pointed to the pool or pools that support that private mempool feature, and then you're also trusting the pool. So you're still giving them the transaction, they're aware of it, it's just not being globally broadcast. And so that's a centralization pressure on Bitcoin because presumably people using a private mempool, they're going to be paying higher fees for that feature. And those higher fees are only going to the big pools that provide that functionality that people are aware of and know how to use. And so you get the sort of centralization pressure where the bigger mining pools are able to make higher revenue because they are the only ones providing this private, quote unquote, private mempool service that's paying them more. And so they have an asymmetric advantage over a private, solo Bitcoin miner or a smaller Bitcoin mining pool. And With this sort of a system, it would be totally egalitarian. So every Bitcoin miner, whether you're a solo miner running, a single, block eruptor that you bought back in whatever the hell that was, 2014, or whether you're, a giant mining pool, you have equal access to the transaction flow and the transaction fees from that private mempool. So it's better privacy for the user. They potentially get 100% of the Bitcoin hash rate working on their private transaction instead of 10, 20, 30% having to wait 2, 3, 4 times as long for their private transaction to get included. So they get better privacy, faster transaction throughput, and we flip it around and make sure that everyone in the Bitcoin mining ecosystem can tap and use that private Bitcoin mempool. So that's another thing that, that one doesn't really line up with the Hemi protocol specifically. Like, it doesn't increase functionality for, say, HBit VM like the MEV marketplace does, or, it doesn't do anything for tunnels or, ZK provability of Ethereum and of Hemi for Ethereum settlement. But it's a sort of new piece of Bitcoin infrastructure that we can build on top of Hemi. And so we kind of think of that as a separate project, although that's further down the roadmap, but it's a cool thing that's on our radar and a nice way to contribute back to Bitcoin and show how, L2s on both Bitcoin and the Ethereum side can actually do things that improve the usability and privacy and security of the Bitcoin base layer. Beyond that, there could certainly be other apps that we think of internally that are interesting. There's a couple others that we have on sort of the back burner / skunkworks list. Some things for, interesting Bitcoin DeFi primitives, some new ways to interact with Bitcoin that, maybe don't specifically need advanced, uh, robust protocol level integration. They can just use HVM as a consumer of it like anyone else could. But they're cool things for the Bitcoin ecosystem that, increase people's ability to get exposure to Bitcoin in, new and interesting ways, things like that. So won't talk about any of those because they're still very much whiteboard ideas, or, a couple of them are, kind of crude MVPs that we've been playing with internally. But as time goes on, especially as we expand the team a bit more, you could start to see some of those additional Hemi, Hemi team created, but sort of separate apps on Hemi that are fun. We also have some people in both the Hemi team and the broader sort of block ecosystem who have been personally playing with creating some interesting little primitives and things that could run on Hemi. So we'll see some of that. And we also do have some partner protocols that are working on interesting things that are related to their product that could be launched either on Hemi or across many chains, including Hemi, depending on whether they actually need HVM specific functionality or not. And so you will see some of those, but that's not really coming out of the Hemi team. That's coming out of sort of partner protocol teams, if you will.
And let me sum that up really quickly. We are, hackers, builders, things like that. So we're gonna keep, hacking on new projects and building new things. But ultimately, our biggest, goal is the, health, construction, and advancement of the Hemi network. That being said, if there's something you want, don't wait for us to build it. Go and build it yourself. Crypto is open source. That is the, half of the point of this entire space is supposed to be, the DIY mindset of, the code's there, the network's there. Get your hands dirty and do something. We would love to see that. That's just the best way. That's the way this, everything in this industry and every network progresses the best. So we're going to keep building, but that doesn't mean you shouldn't.
And that's a great segue to my weekly plug for the Builder role, which is readily available in Discord. Josh, if you don't mind linking that in the chat, I would appreciate the hell out of that. All right, we are moving on to some token related questions. The KYN Star asks, what is the roadmap with timeframes for driving more Hemi token adoption and onboarding more people?
Good question. So a couple different pieces to that. The main sort of economic engine behind Hemi token / VE Hemi staking system, that's going to evolve over time as we decentralize more parts of the protocol. So we're currently in the stage of incentivizing VE Hemi. And again, as I mentioned earlier, for anyone who wasn't on in the original recap, we should be doing the new VE Hemi distribution from late October up until the current date. by end of this week. So keep an eye out for that end of this week / possibly Monday. So that's coming very soon. But for the VE Hemi side, basically right now we're in the stage of getting more tokens staked on VE Hemi to create enough economic security to be able to decentralize features in the future. And then as different parts of the protocol get decentralized, those create additional revenue, some of them organic, some of them subsidized by emissions for VE Hemi stakers, because now they're actively taking part in running and securing different parts of the protocol. What that looks like is, first thing, the MinerFi system. In order to be one of the entities that runs part of the sharded key system, that will require staking VE Hemi, a certain amount of VE Hemi, or having a certain amount of stake weight, to then participate as a operator of the sharded key system that maintains sort of the transient master Bitcoin wallets that manage all of the deposit addresses securely. And then that generates actual real external revenue from people coming in using the fast bridge system, using the DeFi router. The second will be ZK provability. And so that one's more of a protocol subsidized thing, but there may be ways to expand that in the future with Chain Builder to create sort of an aggregated ZK proving system where the ZK proving budgets of the L3 get routed through use of this sort of more generalized ZK proving system or ZK proving incentivization system on the Hemi L2. And so that could, initially start out with Hemi tokens just coming out of emissions, but could eventually transition into being an actual yield generating product for the protocol that's collecting a portion of the ZK provability fees and funneling that back into the VE Hemi system. The next one's HBit VM. So we're targeting Q2 for that. There's two parts of HBit VM that need VE Hemi for economic security. So there's the Covenant emulators, who are very short term. They start up, they participate in this collaborative key generation and transaction graph signing for the HBit VM vault Bitcoin transaction graph, and then they're done with their task. And so that needs short-term, sort of short-lived VE Hemi economic security to make sure basically that they stick around and actually do their part of the protocol, because if a bunch of people don't do their part of the protocol, then it has to be redone and it slows down the protocol. But the more important part of that is operators who are long-term entities that act as pre-coded in liquidity providers, or LPs, for tunnel withdrawals. And so they need VE Hemi positions that are staked for a long period of time, and they need quite a bit of VE Hemi stake so that there's sufficient economic disincentive for them trying to, do an invalid HBit VM vault withdrawal or something similar. And so all of that generates kind of similar to the MinerFi system, but much larger in scale, additional revenue from deposits and withdrawals in and out of that system for construction and unwinding of HBit VM vaults that hold the underlying Bitcoin backing Hemi BTC. So that's going to be another external revenue producing source that feeds back into the set of people in the VE Hemi system who are actually actively participating in securing that protocol, either through, again, Covenant emulation, or people who have the capital and long-term interest in being LPs, or providing that LP role to the system to facilitate withdrawals by fronting withdrawal liquidity when vaults are unwound. Then there's decentralized sequencing. So that's going to start as protocol subsidized from emissions, but eventually that's going to transition into a shared sequencing system that is going to be able to support many L3s in the Hemi ecosystem. And so for each L3 that's producing its own value with either its own token or collecting fees and using either ETH Hemi token for transaction fee revenue, that obviously, as we expand that to a shared sequencing system, that's going to be based around, again, VE Hemi staking. So any external revenue that L3s are creating, that they are funneling into sequencing security or sequencing performance, they're kind of two sides of the same coin in sort of a way. That's all additional external revenue created by L3s that's getting funneled through the VE Hemi system. There's going to be, obviously, in the shorter term, governance voting. There's going to be things with other protocols. So we have, and again, this is kind of covered a little bit in the original Hemi economic model, but we didn't expand into the details, and hopefully we'll have more details in this component in the coming 1 to 2 months. But the sort of long-lived protocol liquidity system, protocol-owned liquidity system, where it's a sort of evergreen fund that is used to fund things in the Hemi ecosystem and then recapture value that it creates. So, for example, a developer comes in and wants to build some new interesting DeFi protocol. the Evergreen DAO would be able to fund them and let them build out the project. That increases utility for Hemi because there's now this new DeFi primitive you can use on the Hemi network. But also then a portion of that protocol is either revenue or token if they're minting a token or whatever makes sense based on the structure of the protocol. That would go back into this protocol and liquidity system, and a portion of that could also go back to VE Hemi stakers for voting on those allocations with governance to actually fund these projects and appropriately vet them to make sure they're actually going to get built, things of that nature, or they've do an initial round of funding and then make sure that they're delivering on the roadmap before releasing more funding or community incentives to build out their ecosystem on Hemi or whatever. But that's another potential revenue stream that intersects governance and is a little simpler because it doesn't require participating in some of these more complex parts of the system's decentralization. And then I mentioned shared sequencing. That also comes with a shared DA system. So shared sequencing, shared DA, when you couple the two together, you get a lot of interoperability benefits. And so for MEL3s, that shared sequencing and shared DA layer eventually, that's another way to create revenue, funnel that back into VE Hemi because it's using VE Hemi for, again, economic security to make sure that system runs correctly. Beyond that, there's other stuff. Part of the ZK proving system that we're building for HBit VM, it kind of acts as a public good. Well, it does act as a public good, where we're using it obviously for Hemi itself and being able to create these compact self-contained proofs of Bitcoin, Ethereum, and Hemi state that nobody can forge unless they 51% attack both Bitcoin and Ethereum, which is a way higher security threshold than any other current ZK proving system for any of those chains. And so people can reuse those proofs in interesting ways for their own protocols and basically add on to them. So we already have this base layer of Bitcoin, Ethereum, and Hemi ZK proven, and the three of those collectively can secure each other. And so you couldn't just ZK prove Bitcoin and Ethereum because you need some connective glue between them that keeps one honest in the view of the other. That's where Hemi steps in because it's an L2 to both of those underlying L1 chains. It can see both, it can interpret data from both, it can send data cross-chain to Ethereum if it needs to. It can look at the current Ethereum state, it can extract data from these new pop publications for the system from Bitcoin and compare them to Ethereum state roots. And so you have that connective tissue between the two networks that essentially lets you prove one in the context of the other to keep both chains honest. And so once we have that base layer built out, there's a lot of things people can build on top of that, either purely in the Bitcoin ecosystem, purely in the Ethereum ecosystem, or obviously as Hemi specializes in things across both ecosystems. And that's another potential revenue stream for that on-chain decentralized ZK proving mechanism, where we can have, the protocol is paying for, sort of that base proof. But then if people want proofs of, say, their Ethereum L2 or their Bitcoin L2 or their other isolated protocol that touches one or more of those chains through some other interoperability mechanism, they could then shelve off the computation of that work and the composition of the sort of baseline HBit VM proof system proofs with these additional external protocol specific proofs to deliver, Hemi secured, Bitcoin secured, Ethereum secured, ZK proofs of all those chains and their additional chain and context between them. So that could be another additional angle, probably a little less interesting than some of the other stuff I mentioned. That's a lot more concrete and has a little more lock-in because, of course, projects could go and spin up their own ZK provability system and do a similar thing, but there's a lot of convenience and utility to using the proof system that's actually built to work with these underlying Bitcoin, Ethereum, and Hemi combined aggregated state proofs. So I'm sure there'll be more stuff in the future. That's sort of the hot list for the next, 12 to 18 months here for economic utility for the Hemi token. Again, mostly through the VE Hemi system, serves to decentralize Hemi, serves to secure Hemi, and then has a lot of ways to produce external revenue that then, or external, protocol revenue, or in some cases, not technically revenue, but income to different protocols that a large portion of that's going back into the VE Hemi system. And then the other is just plain old adoption. So as we improve, add more features to HVM, as we make it easier to use, as people start understanding HVM more and building apps around it, and we get more utility on chain, that's again protocol revenue from just a pure gas perspective, and that also feeds into the Hemi token economic revenue system.
All right. Thank you for the detailed explanation, sir. On to a VBK question. Poison asks, when will the first Hemi distribution to registered VBK users take place?
Probably somewhere in the next weekish. Exact date TBD, but soon. We've actually seen quite a few people register, so we got quite a good first chunk for the first distribution. So probably next weekish.
All right. Great news. Okay. Alpha asks, where can I see Hemi buybacks using collected gas fees?
So whenever we do the distributions, we link to the transaction showing the purchase of the Hemi tokens on an on-chain DEX and then the burning of them. So for the next distribution, we'll do the same thing. That's a little ad hoc. In the future, we may add some sort of burn contract that tracks it a little more cleanly. But for now, basically each time there's a distribution in the post about it, or depending on if there won't be a hippo for this distribution, but in the future as things change, there may be hippos for new distribution models and stuff. The actual buy and burn transactions will be listed there. So a little disorganized, but it's always will be posted in some format with each distribution, and then eventually we'll probably move to a on-chain system that has a little better visibility and tracking, so you'd be able to look at it from say a Dune dashboard or something like that more easily with just on-chain data. But that's a TBD item, lower priority, because we are at least posting the information if people were to go actually look at it on-chain and trace through the revenue coming from the fee collector addresses to then, you know, safes that manage the revenue distribution to the buyback transaction to the burn transaction. I think the last one actually we tunneled it to Ethereum and then burnt it on Ethereum, if I'm not mistaken. And we'll probably do the same thing here. So you could also track it with the same pattern if you looked at the way the buy and burn was done with the October distribution.
All right. Just real quick, I want to give a shout out to Ajit for boosting the server. Thank you, sir. Just saw that in chat. All right, moving on to some HBitVM questions, both from Mudacon. What is the reception from the cryptosphere regarding the HBitVM white paper?
Overall positive. It hasn't got a lot of distribution yet because we haven't put out a lot of easier to understand, more breakdown content. So I have talked with a couple people who are working on other BitVM adjacent technologies, and as some things there mature, we may announce partnerships and interesting things with them. We'll see. We're still vetting how the two technologies would work together, but we have got good feedback initially. Hoping to get sort of more distribution, more eyes on it as we start putting out some easier to understand content that kind of gets people to understand the premise a little easier, and then if they're interested, then they jump into the white paper instead of just this monolithic, somewhat hard to initially digest piece that a lot of people probably aren't taking the time to fully look into without kind of having the aha moment from easier to understand kind of initial blog post tweet content. So expecting more input, more feedback as we get that content out. But so far, discussing with a couple people building BitVM style technologies they're interested in, and there could be there definitely are some cool ways to reuse what we're doing in a way that benefits other protocols and also benefits Hemi back from their use of it. And so as some of those solidify, we'll definitely be talking about those, featuring those, but nothing to announce at the moment because that's still sort of early discussions.
All right. I'm just looking ahead. There seem to be a couple other questions regarding ZK proof, and I know we've done those in the past, and you've actually given like a pretty good breakdown. The question is, what is a ZK proof? It's actually making me think, should we do an engineering breakout AMA in the next couple weeks all about ZK provability?
I would love to, and actually that the timing works out well because we'll have our initial HVM state transition ZK proof system probably open source in the next few weeks. And so that's something that people could play around with and look at, and then come to the engineering AMA and actually discuss the implementation details if they're interested. So yeah, why don't we tentatively put something on the calendar maybe for the second week of February?
Yeah, that's perfect. All right, so Alondra, I apologize for not getting into your question right now, but we're actually going to have an entire breakout session regarding that. So,
I'll do a
all
super quick version of that. I promise, like, actually super quick, because I know we're already almost at time here. ZK proofs, basically, ZK stands for zero knowledge, and the point of there's two main aspects of a ZK proof. There's a privacy component, and there's a verifiable computation component. And for what we're using ZK proofs for at the moment, all we care about is the verifiable compute side of it. And so it's actually a little confusing the way the space uses the term, because everyone calls them ZK proofs, even if they don't care about the zero knowledge or the ZK part of the ZK proof. When you actually look under the hood, there's two main families of ZK proofs. And so you have ZK Starks and you have ZK Snarks. And there's other variants, and there's a lesser variant of a ZK Snark called a ZK Snarg, SNARG. But the important part is all of the current efficient compute proof systems we have also happen to also be ZK. And so even though for our use we don't really care about the ZK functionality, the zero knowledge privacy piece, there are some things we're looking at doing in the future that would benefit from the privacy part, but we really care about the efficient compute part. And so give an example of how that'd be used. Right now, if you want to prove on Ethereum that something on Hemi happened, it is if you were to prove it naively, you would have to recompute the entire Hemi state on Ethereum, or do like an optimistic fault dispute game where people run 100 million compute operations opcodes on a CPU, and walk through processing a ton of Hemi blocks, and all the EVM execution, the embedded TBC node, that processing Bitcoin blocks and indexing them. And so it's pretty much impossible, other than again the like optimistic fault dispute type system, to verify the state of one chain on another, because you basically have to nest that chain inside the other chain. And we kind of did that. Well, we did do that with HVM and the embedded Bitcoin node. But in practice, unless you're doing things like that at the protocol layer, you can't just spin up a chain and then take all of the computing required to validate the chain and then program that in an Ethereum smart contract. But with ZK proofs, and again, don't care about the ZK part, but we care about the succinct, non-interactive argument of knowledge part of it. That's the SNARK, succinct non-interactive argument of knowledge part of the proof, which is basically, in the case of ZK snarks like Groth16, a extremely efficient constant time verification of any arbitrary computation that you can express as a circuit. And so what that means is basically anything you can write a program on your computer to do, you can construct a proof that it was executed correctly, and you can validate that. Anyone can validate that proof once you generate it in milliseconds on their computer. Whereas that translates to on Ethereum, less than a 1 million gas, usually 3 to 700,000 gas, depending on the proof system. And so what that means is you can take a computation that would, be impossible to run on Ethereum itself, and even if you ran it on your computer, it could take weeks to run. You could generate a ZK proof of that if you had the compute power, and Ethereum could validate that proof, and it could do something useful with that proof in constant time. So whether your computation takes a second to run or a year to run, if you can construct a ZK proof of it, Ethereum can validate it in less than a million gas. And that obviously extends to other EVM chains. From Hemi's perspective, the reason we care about ZK proofs at the moment, and again, there's future stuff that uses the privacy component, like private DEX L3 type structures, the private Bitcoin mempool thing I talked about, things of that nature. But for what we're currently working on with ZK provability, what it really means is that we're able to compress all of the compute and validation of everything that exists on Hemi, including the embedded Bitcoin node, the precompile calls from smart contracts to that node, the in-EVM sort of standard execution, the fact that the blocks that actually have the transactions that we're claiming are valid are correctly published to Ethereum in DA, and they pass POP fork resolution, or win at POP fork resolution. All of that can be compressed into a single ZK proof that then proves that Hemi is in a certain state. And so once you have that, then you can use those proofs on Ethereum is the simpler example. I'll get to Bitcoin in a second, but on Ethereum, you can use that to prove that, say, somebody initiated a valid withdrawal of assets from Hemi back to the Ethereum L1. And here is a ZK proof that the Hemi chain currently looks like this. it is indeed the correct version of the Hemi chain. There's no alternate version of the Hemi chain because we've proved a negative in the bounded space of the potential Hemi publications to Ethereum DA. We proved the execution's correct. The end result of it does let this user withdraw this asset. And then the Ethereum side of the tunnel contract knows that it is now allowed to let that user withdraw those underlying assets locked in the contract, and that it is perfectly lined up and in sync with the other side of that transaction, the burning of the L2 tokens and initiation of withdrawal on the Hemi side. On the Bitcoin side, it's a little more complex, but it's the same general idea. So Bitcoin with HBitVM, or BitVM in general, but HBitVM specifically here, the ZK proof demonstrates a valid withdrawal has executed on Hemi chain and is supposed to be allowed to, or is supposed to be facilitated on Bitcoin by somebody fronting liquidity to them and then being able to then turn around and withdraw the underlying Bitcoin that they fronted from one of the HBitVM vaults. But what we can do with the ZK proof side specifically is, because Bitcoin has a lot of limitations, so the Bitcoin scripting language is extremely limited. You can't do a lot with it, or if you do a lot with it, it becomes very expensive to do. Bitcoin also can't see itself, so there's no self-introspection. So Bitcoin, when you execute a Bitcoin transaction, it doesn't have context of what else is happening on Bitcoin. So like on Ethereum, you run a transaction, it can look at the state of other smart contracts, it can see what the previous block header was, it can get the previous state root and validate a ZK proof against it, yada, yada, yada. Bitcoin can't do that. And so even though, BitVM style constructions before HBitVM let Bitcoin effectively validate a ZK proof, which was previously thought impossible, that ZK proof still needs context. And so if you validate a ZK proof on the Ethereum side, it has that context. It can look at the current Ethereum state. It can validate KZG proofs against what it knows to be state roots of KZG commitments that are in the recent Ethereum chain, stuff of that nature. Bitcoin can't do that at all. A Bitcoin transaction has no idea what block it's in. The only context a Bitcoin transaction has is sort of by proxy the current timestamp. And so, or an approximation of the current timestamp. And so with HBitVM, the sort of main unlock was being able to use Hemi's position between Bitcoin and Ethereum to create self-contained proofs that don't need that additional context. So they can prove the canonical state of Bitcoin using Ethereum as an anti-censorship layer. They can prove the canonical state of Ethereum without the risk of zero knowledge, nothing at stake attacks by using publications of Ethereum state attestation data to Bitcoin. And by doing that, because we sit between both chains and have knowledge of both chains, that lets us construct ZK proofs that can be validated on Bitcoin. The critical unlock here is they don't need any context from Bitcoin except an approximation of the current timestamp. And so now that unlocks a lot of new things that you can do on Bitcoin on the ZK side without needing to make changes to the Bitcoin protocol that would provide that additional context, or have workarounds like the Superblock light client emulation system or things like that other projects have used to work around that lack of context in which to validate a ZK proof on the Bitcoin side. So that ran a little long, but short answer, ZK proofs, we're using them just to prove something happened somewhere and it was correctly verified. And then we can use that for all kinds of cool cross-chain stuff. And then the main unlock with HBitVM is some innovation on the ZK proving side and the consensus sort of mutual provability side that lets us make self-contained ZK proofs that can be extremely useful in Bitcoin in a way that other ZK proofs can't, because they don't have the additional context they need to truly validate everything they're supposed to validate.
All right. Thank you, sir. And this is why we are having a special AMA regarding ZK proofs, because there is no way that we can do this do this question and still have time for others. But we will have a very special AMA all about ZK provability in the next couple of weeks. We are a little over time. Josh, can we save the remaining questions for next week? And we can just put the newer questions integrated with them. I want to make sure every question gets answered, but awesome. I apologize that we didn't get to all your questions this week, but we will cover them next week. I want to thank our community moderators and all the amigos for turning out today. Very detailed and incredible answers from the team. Also, there is a Rumble session in the Hair server, so don't forget to join. Immediately following Midweek with Max. Also, the Hemi Station channel is still open for your comments, and we have been actively looking at it as we work towards what Hemi Station is. And in addition, the what the hell does it stand for? Oh, Jesus. Sorry. I just blanked. The Hamigo of the Week t-shirt contest is running until Friday. We will start the Hamigo of the Week activity rolling out next week. So this is for the exclusive merch drop, the design. So make sure it's on brand with Hamigo of the Week, and we'll get that going for you. I want to thank the community moderators again, all the amigos for tuning in. And sorry, there is one quick question we can cover real quick. Tapity asks, is there any connection between Block and Hemi?
Block is sort of, you could think of Block, this isn't perfect, but sort of as a project or idea incubator. And so they spin up a bunch of different ideas. And then as those mature and become sort of have a life of their own, a team of their own, then they get spun out. And so they're still part of the Block ecosystem, but they are, their own legal entities with their own, development company, foundation, etc. And so Block basically funds initial ideas, builds them up, constructs teams for them. Block also does some stuff that's, inside of Block itself and will stay a part of Block that, it doesn't make sense to spin out. But, things like Hemi, if you've been following the more, broad Block ecosystem, things like Atmos, Odyssey, further back in the day, Vesper, Titan/Lumerin, all those sort of, I don't know the exact, history of all of those because some of those were very long ago. But those were all sort of spun up and incubated inside a Block and then spun out once they reached a level of maturity to operate as their own companies and projects and teams. So obviously it's a close ecosystem where some teams share resources if one team has extra smart contract development capability and another team needs it. There's a lot of borrowing resources, sharing ideas, everything in the Block ecosystem, vetting each other's ideas and giving feedback. So it still operates as a lot of very closely connected, interrelated projects, sort of under that bigger Block umbrella. And JCV's been here since almost the beginning. I don't know if he has any additional comments on that.
Yes, I have been here for quite some time. But no, that's a pretty good summary that, there are a lot of projects that started at Block and some of them end up, spinning off on their own to some degree or other. And others remain part of Block. We do, there's resources that get shared across them because that buys us efficiency. It allows, something like Hemi to start out with significantly more years of experience, in terms of the staff than it would have otherwise. So things like Hemi didn't have to start at zero by doing it this way. But it also means that we remain close with all of the other projects. So again, there's some more knowledge transfer, some more, when some, let's say, hypothetically, if something horrible came out in the NPM ecosystem security-wise, right? Totally unthinkable, that would never happen. As long as, someone in one of the, related company knows about it, we definitely make sure we share knowledge and things like that. So it lets info spread a little faster. Just there's some efficiencies and some just positive things that come out of the close, but none of us can really speak to the exact legal way they're split up because who the shit understands how lawyers do things? That is,
And I'd say operationally, it might not be a perfect example, but it's kind of partway between a bunch of independent companies that are in like an accelerator and a bunch of projects that are all under like one single monolithic corporate umbrella. So, tons of projects under one company. There's a lot of, cross team sharing, cross resource sharing. And then you take it to the extreme of, a lot of completely independent companies, but they're in some common like incubator or accelerator or something. There's still a lot of like knowledge sharing, but it's a little more separated, more degrees of separation. And so the Block setup's sort of a hybrid of those where things operate as their own legal entities and do have their own teams for the, like other than some smart contract stuff, we don't really share engineering resources with other projects. Like everyone in the core and UI engineering team is 100% dedicated to Hemi. Other than, like JC was saying, cross-chain, knowledge sharing. If there's an NPM bug that we're worried about and we're fixing, or we see could be an issue for other projects or whatever, we'll let them know. And there's, here's what we're doing. Here's, how we're addressing the problem, or here's the steps that we put in place proactively to prevent that from happening. And you should replicate these on your side, right? So there's a lot of that cross sharing, but it's more intimate than you'd get with just a bunch of unrelated projects that are joined together by being in some accelerator, incubator, or whatever. It's kind of a hybrid of that versus projects that are under a company and actually share tons of human resources. So you have with a single corporate structure, you may have a project, 3 projects, and one person is touching all 3 of them in some engineering capacity, right? So it's basically a hybrid between those 2 models, I'd say.
All right. And final question from Antonio. How how are all of Hemi network components connected? What do they do and how do they work? I'm just kidding. He did ask that, but there's no way we can answer that one right now because
Antonio, I
I
think that'd be a great question for you to answer, actually.
yeah, actually, Antonio, why don't you take this one?
Yeah, for sure, for sure. I think maybe next time.
All right.
But yeah, for sure I'll answer that.
That's
All,
another 20-minute deep dive.
yes. Join us on the next Midweek with Max, where Antonio will explain how all of the Hemi network components are connected, what they do, and how they work. So we'll lead off with that and then get into further questions.
We'll try to add some more components between now and then just to make it harder.
Please do, but don't tell him about them, so that way it makes it a trick question.
We are actually doing it. We have the new ZK TBC translation and proving system. So that is yet another component.
This is looking better and better by the second.
We wait long enough, we can use a whole midweek next just to cover the architecture. Hopefully not. We are actually, the recent refactor we did actually cut down on the number of components and consolidate things in a way that made sense and made everything easier to manage, easier to run. So as much as we joke, there's I forgot who originally said it, but there's a great quote for software development. I'm going to butcher it, but sometimes the most effective developers spend more of their time deleting code than writing code. And that's there's certainly times where that rings true, especially as you get sort of sprawl of a bunch of different components and pieces that were built separately, but eventually you kind of see the bigger picture and see how they should all fit together and be more efficient and reduce duplication. So as much as we joke, the goal is to reduce the number of components as much as possible, but obviously some stuff like a new ZK proving system necessarily introduces new components that don't really aggregate into existing ones super easily.
All right, folks. And with that, we are not dramatically over time. We've run longer than this, but we are over time. I apologize for not getting everyone's questions. We're going to save them for next week. Alpha, my apologies. I tried to ask as many questions as possible. I got one of yours in, got a couple of Mudacons, but there's definitely some more in the pipeline that we will address next week. So thank you all for joining us. Please remember Rumble and the Hair server immediately following Midweek with Max. The Amigo of the Week t-shirt contest is open. Merch available in the Hemi community collection of the merch store. There's my weekly plug. Builder roll readily available. And with that, let me turn it over to Max and team for outros, and we'll see y'all next week.
All right, sounds good. And I do see one question that's super easy to answer and kind of time sensitive. So the Luctatio asked, when will the new PopPad algorithm be deployed to mainnet? So like I mentioned in the intro, testnet, it's been deployed and it'll activate today around 2 p.m. Eastern, 2 or 3 p.m. Eastern. I forgot what exact time I set it to. But so that's coming out on testnet. And then mainnet, we are waiting on a final audit from the auditors on the pop payouts v2 contract. So they're targeting the last week of January to have that audit done. And so assuming testnet testing looks good and the audit comes back when expected, we're currently targeting a mainnet launch in the first week of February. So again, depending on audit, or if we do find any issues in the testnet testing, that might be second week of February, but that's the current target is first week of February.
All right, thank you. See, we did get one more question. All right. I think that is a wrap for this week. So thank you all. And anything else from the team for outros, or should we just Irish goodbye this?
Yeah, quick outros. So stay tuned for open sourcing some of the cool ZK bits in the coming weeks, and then we'll do an engineering AMA specifically on ZK and HBit VM, obviously. Since we already did an AMA, but people have had more time to digest it. It's related to ZK. We'll bundle those together into one breakout engineering AMA probably in the next 3-ish weeks here. I think we were talking about the second week of February when it was brought up earlier. So stay tuned for that. Stay tuned for more digestible HBit VM content. We'll be getting out on the blog and Twitter hopefully soon. I keep adding more stuff to it to try to make it easier to understand. So that's coming soon, still being actively worked on. And then, yeah, beyond that, stay tuned for the announcement about the Jovian hard fork activation and node upgrade steps, both for testnet and mainnet. That's probably a few weeks away, but coming down the pipeline. And beyond that, I think that's pretty much everything on our side. We'll also be announcing more updates on the MinerFi system as that starts to come together with the smart contract MVP and eventually get to a testnet testing stage for that. And with that, we will see everyone next week.
Take care, amigos.
Appreciate you all.
Bye bye.
All right. Love you a lot.
Cheers.